Alright, so today I'll be talking about memory layout for the C programming language. So, first off, first component of this memory layout is the stack. So, you could think of a stack as a certain window that each function call opens. And so, if you make a function and you give it arguments, those arguments are within the stack. And you can think of a stack like a specific memory layout just for a function, and so this would grow downwards. Heaps are general memory. It's like dynamic in a sense that you could access this memory from any function or like any even the global space, right? You could access anything in the heap, and so you would rely on calls such as malloc, realloc, calloc. Those all sort of make space in memory to store certain values and objects. Then you have data. The thing about data is that it's fixed, but you can store variables, global variables, and these variables could be accessed just about anywhere. So if you're trying to make an array with a max length, you would basically set a max length in the global variable space, basically just outside of every function. Oh yeah, I forgot to mention, heap grows outwards, or grows upwards. So that means every time you make a call to an empty heap, it would just get closer to the stack. And you can sort of like make both of these go towards each other. Anyways, moving on to text. So this is where the instructions are stored. So basically, every piece of syntax that you write, it is stored in memory, but it's a specific portion of memory that just stores each line of text as, typically it's 4 bytes. Yes, it's typically 4 bytes. And each line of code that you write, it's taking up space within the text portion of the memory layout. Anyways, we have a standard library for C programming, and there's 3 fundamental ways to manage your heap, and it's by calling malloc, free, and realloc. I already mentioned that malloc is a way to sort of create space in the heap to store variables and objects. But free, as you can tell, it does the opposite. It clears out that space in the heap, so then you could sort of reuse the space that you cleared out, or just avoiding, if you want to avoid a memory leak error, and that is very important for basically all of C programming and all of lower level language programming. And then realloc, sometimes blocks of memory that you create in the heap must be resized. So for example, if you're increasing the length of an array, first off, an array is a set length. It's a limited space of length depending on how you initialize it. So if you call int array of 5, that's basically saying we've just allocated around like 20 bytes to store our integers. But then what if you want to hold 6 integers? You need to basically reallocate the memory block to hold 6 integers, and by doing that you sort of have to point back to the pointer that you created by making the array, and then basically creating more space for that extra integer. And we have these operations. For example, let's say we malloc 100 bytes. So we're looking at a heap, and I mentioned before that heap grows outwards, or upwards, sorry. And then let's say we also malloc another 10 bytes. So that 10 bytes gets propped up onto here. And let's free the 100 bytes that we sort of called. And so now you're just left with this sort of floating block of memory, right? Gravity doesn't exist in a memory layout, so that's why it's just stuck in limbo. Anyways, there is something that happens if you request too many bytes with this sort of floating block, and it's that your memory will now split, right? I mean, first of all, a heap will always want to grow upwards, so it would try and allocate those first, let's say, 25 bytes past R2. And then once it hits the ceiling, where does it go? It goes in the remaining space it has, which is at the bottom. And so your memory block fragments, and yeah, we get this fragmentation. Anyways, your function calls, or your sort of tools to allocate memory in the heap. So first of all, the variable type, it's not an integer, it's size underscore t. It acts like an integer, but I mean, first of all, this is unsigned. You can't have a negative size. At the same time, also, what does size indicate? Size indicates number of bytes. So the C programming language sort of creates these constraints within size t, so then you could not accidentally bombard the heap with a large amount of memory allocation. Anyways, calloc is like malloc, but it initializes everything to 0. So it has 2 arguments. One is count, second is size. So if I were to, if I wanted to make an array of, let's say, 4 integers, I would just do calloc for size of int, and that would basically ask it would basically make, first of all, 16 bytes in the heap, but then also initialize them to 0. So you just get an array, or an integer array of just zeros with length 4. Yeah, so that's what calloc does. Realloc. Right, so realloc is under the assumption that you already have a preserved location, a specific location for the object pointer in the heap. Also, size. So basically, realloc could return a different pointer address, and so not pointer address, but like just another address in the heap. And so you would just reassign, if you wanted to reassign a pointer or resize an array, you would do realloc and then new size. Yeah. That's essentially how you use realloc in most programming situations. Because sometimes your memory could fragment. So what the heap does is that it just takes the entire requested block size, memory block size, and then just moves it to a space where there is enough space to have a full non-fragmented block of memory. And so that's why you would need to reassign your pointer to realloc, or the result of realloc, because realloc just, it returns an address or a pointer to that specific place in memory, just like malloc, right? You have to assign a pointer to malloc, and also calloc as well. Free, well, free is interesting in the sense that all you need to do is just input a pointer, and it already knows the size of that pointer, so it just frees everything within the block of memory that it holds. So if you have previously created the array of 4 integers with calloc, then you just do free array, and that should basically free up the memory in the heap, and you have successfully avoided memory leaks.